This conference will now be recorded.
Yeah, so good evening, Deepa. So today, what we'll do is we had recently completed one chapter, that is motion in a straight line, and this is very important for competitive exam and all. So what I'll do today, I'll teach you how to solve numerical problem on this chapter. So today's class will be numerical problems based on this chapter. So we'll take up one by one question and then we'll discuss how to solve. So this is the first problem. Suppose a car travels uh, first one third of its distance at a speed of 10 km per hour. In the next one third distance at a speed of 30 km per hour, and the last one third distance at a speed of 60 km per hour. What is the average velocity of the car? So this class is going to be kind of interactive class. Okay, so you can tell me whether you can do it and how to do it, and then we can just discuss and solve the problem. Okay, if you don't know, then I can proceed. So Deepa, can you read this problem carefully and tell me whether you have some clue how to solve it and all? You have to speak, Deepa. Can you unmute and say whether have you read it? You just read it and then tell me whether it is understandable or not.
Yes,
Okay,
sir.
then you are not speaking. So is it understandable, the problem? So a car travels fast one third of its distance. Okay, I'll just explain the problem. So this is a problem where what is the aim? You have to find out the average velocity. Okay, what is the average velocity? The question is on average velocity. But see, we know the definition of average velocity is that the total distance, sorry, total displacement by total time interval. Suppose your displacements are s1 plus s2 plus s3, like that. If it goes up to n, then sn, and time required for traveling this, okay, the time interval for this displacement, if this is t1, then this is t2, then t3, like that it goes up to tn. So you have to find out the displacement, okay, and divided by the time intervals. So you have to take the ratio of the total displacements covered and to the total time interval it takes. Okay, so look whether these informations are there or not. Here you have to find out the average velocity. We have to read the problem and we have to find out whether these informations are given or not, or time is given or not. Okay, this is the fundamental equation, but we can vary. This equation can be varied. I'll tell you according to the informations given, we can just write this formula of average velocity in different way also. I'll teach you how to write that. Let us read the problem once again. Can you tell me whether the displacements are given? Whether the displacements are given? The answer is yes. Suppose a car travels fast one third of its distance. Suppose the distance is d. So I see the car is traveling one third of its distance, so d by 3. If the total distance is d, then d by 3, that is s1. Okay, then the time is not given, so this one third distance is traveled by the car. The speed is given. Look, the speed is given. So v1 is given. Speed 10 kilometer per hour. But what we needed? We needed corresponding t1, isn't it? Can you find out t1 from the given information? The answer is yes. We can find out this t1 can be found out by s1 by v1. Okay, do you understand now? So the second, see, next one third distance, that means s2 is another d by 3, one third distance traveled with a speed v2 is given as 30 kilometer per hour. Okay, look, this from these two informations we can find out t2, right? Again, the last one third distance, that means s3, if I take, that is d by 3 again. This is the s3. So there are three displacements. Okay, and the velocity is also given as v3 60 kilometer per hour. So these are the informations given. You can find out t3 from this and then you can do it, right? So look, I'll just, so Deepa, do you understand? Do you understand this? Whatever steps I have done,
Yes, sir.
you understood? Can you solve it now by yourself, or I'll complete it? Okay, just see for today. If you get any this type of problem, you just learn today and try to solve this kind of problems if you get some time later. Okay, so what I'll do, I'll just solve for you today. So look, what we know, the average velocity, this is s1, s2, then s3. I'll write like this, and then see, I'll write here t1 corresponding this time intervals. Sorry, this is t2 and this is t3. Okay, so look, this t1, t2, t3, I'll just convert it. So s1 I'll keep as it is, s2 as it is, s3. Okay, so the numerator I kept like that. Denominator I know v. These are uniform velocities. See, uniform velocities means s is equal to v g. Okay, this is the formula for uniform velocity. The distance traveled by any object in time t, in time interval t, will be s is equal to v into t. That is the uniform velocity into the time. So from this formula we can find out t1. Okay, t1 will be s1 by v1. Similarly t2, okay, and t3 we can write. So I'll not find out the values of t1, t2 and t3. Instead I'll do a simplification over here. Look, so s1 by v1, I'll write like this, s2 by v2, excuse me, and then s3 by v3. Okay. So after doing that, you look in the numerator and denominator. We can do a little bit of simplification. We just take common of this. See, S1 and S2 and S3. See, these are all 1/3 of the distance. 1/3. So S1 is D1 by 3. Sorry, D by 3. Same as S2 and S3. Right? So I can write all of them are S, or I can write all of them as D by 3, D by 3, D by 3 at these things. So D by 3 plus D by 3, because 1/3 of the distance, each case 1/3 of distance. I have taken the total distance as D, so D by 3. So here also I'll be writing D by 3 by V1 plus D by 3 V2 plus D by 3 V3. Okay. Look, now it is very simple. Very simple. If you take common D by 3 from both numerator and denominator, you can simplify it like this. D by 3, you take common, this will be 1 plus 1 plus 1. So 3, and in the denominator also, this is D by 3. So 1 by V1 plus 1 by V2 plus 1 by V3, like this. Okay, so you strike this out. So you get, what you get is, this one. This is 3 divided by 1 by V1. So V1 is this one, 10 kilometer per hour. So then 1 by V2, this part, 1 by V2 is 1 by 30. Okay. And this is 60. So 1 by 60. Now what you have to do, simply just LCM you have to do. If you do it, look, this 60 goes up, and this will be actually, so 60 will be LCM. So 3, this will be 6, this will be 2 plus 1, so it will be 9. Okay. So this goes as 3. So this is 20. Okay. So the answer will be, the average velocity will be 20 kilometer per hour. Okay. This is the answer. See, this problem will be given in other way also, average velocity. See, here the velocity is given with the displacement. So sometime, see, the time interval will be given and velocity will be given. The displacement will not be given. Okay, so in that case, what you have to do, S is equal to Vt, you have to write Vt. So if the same time interval, then you can write 3Vt divided by 3t. So 3t will go away, so you'll get V. Okay. Anyway, so this is the master formula, S1 plus S2 plus S3 dot dot up to n it can go, and the time interval, corresponding time intervals you have to write. If the time is not given, or the time is given and this S is not given, it is given velocity. So sometime it will be given as, like, see, first 3 seconds goes, like, travels with 20 kilometer per hour, like that. Velocity and time is given, but displacement is not given. So this is the first 3 seconds, and second 5 seconds, it, like, next 5 seconds it travels with 60 kilometer per hour. So here the time and the velocity is given, not the displacement. So if the displacement is not given directly, you have to get it by doing V into T, corresponding T's. Okay, V into T. So then you have to divide. All right. I hope you have understood. If you don't understand, you can just ask me now. Is it clear to you, Deepa?
Yes, sir. Clear, sir.
Okay. So okay, fine. Then I'll just move from here. I'll go to the next question. So this question is very easy. Can you read and tell me the answer? There are four answers are given, four options are given. Which one is true? You have to tell me. The question is, see this semicircular path. This is a semicircular track, okay? And it has a radius. If I say this is the center, so radius is r, okay? And P and Q starts walking from point A to reach B. Okay. So suppose there are two persons P and Q. They starts walking towards B, but in different path. One, say P is walking, so P is walking along this way. This way P is walking A, C, B path, and Q is walking directly this way. Okay. Q is directly moving this way. So there are two persons P and Q. Q starts moving in this direction to reach up to B from A, and P is moving in this way ACB. Okay. So now you have to tell me which among these options, like more than one may be true sometime. So which of the four options will be correct? The first option is displacement for both of them are the same. Displacement. So is this true or false? Deepa? Displacement. Yes. So is it true or false? Displacement for both of them will be same. Is it true or false?
False.
So false. Okay. Let me explain you what is displacement. You might have forgotten the definition of the displacement itself. See, displacement means the change in the position. Change in position. This is displacement. Okay. Displacement means change in position. So if I write in terms of mathematics, suppose displacement is, this is delta x. That means x2 minus x1. If this is one dimensional motion, then it has only one coordinate. So in fact, what is this x2 and x1? This is final position. Final position. And this is initial position. Now can you answer whether their displacement is same or different? They both starts from A. Both of them are starting from A. Okay, so initial position is same, right? Initial position is same. Okay, so this much clue I can give you. You have to see they are actually, see, the both of them are going where? They are going to B. They are going B. Okay, they are going to B. So they are going to B. That means the final position is same for both of them. Whatever path that may take, that doesn't matter. But what is the final and initial position? For both of them, whether the final and initial position is same in this case or not. Both of them starts from A. Both of them reach to B. So whether their positions are initial and final positions are same or not. Deepa? Their initial position is same. What about their final position? Is that same for both of them? No, I am not able to hear. You have to speak loud. Or you go to the chat box. You can see like this. You can chat from there. Okay. So the final position also same for both of them. Okay. So the initial position is A, final position is B for both of them. So the displacement is going to be the same. Okay, for both of them. I hope you have understood it. You had some misunderstanding. Now I hope it is clear for you. Okay, I'll clean everything. Now we'll see the second option. The second option is the displacement for Q is smaller than P. So this is not true. The P travels larger distance than Q. This you have to answer. P is going through this way and Q is going through this way. Their destination is B. For both of them, their destination is B. Now you have to tell me P travels larger distance than Q. Distance means what? Path length. Path length. Okay? Distance means path length. So it does not depend on initial and final position. It depends like it is the path length, the total path length what you travel. So can you answer whether this is true or false? This guy, the option C. See how you have to analyze. You have to find out the path length he has traveled. So if somebody is going through this way, A to B, then what is the path length? This is the periphery of the semicircle. Okay, periphery, periphery of the semicircle. So how to find out periphery? So the path length, I say LP, traveled by the person P, it is actually 2 pi r. The radius I said r for the semicircle by 2. Okay, half of the periphery it is traveling from A to B. So this will be pi into r. What about the path length by Q, which is the person who is traveling A to B directly or in a straight path? What is the path length for him? See, the path length is actually 2r for him, right? 2r for him, isn't it? A to B. So path length LQ is 2r. It has to travel all the way through the diameter. Okay. So see this 2r and this is actually 3.14 the value of pi into r and this is 2r. So which path length is greater? So LP, the distance traveled by the person P is greater than the distance traveled by the person Q who is traveling straight away. So now is it understandable? Distance means path length. So the path length traveled by P is larger than the path length Q. So this is also true. So this is true. This is true. And distance traveled by P and Q are the same. This is not true. Okay. So Deepa, do you understand this problem? This is
Yes,
very
sir.
simple, but you have to. Yeah. Okay. Good. So you have to learn it how to solve this kind of problem. Okay. You have to learn it. So we'll go to the next problem then. So this problem is very simple. Can you read this and tell me whether you can solve or not? The problem is a small box slides down a frictionless inclined plane. Frictionless inclined plane. Okay, that means the box is traveling. Sorry, this is inclined plane. We'll actually see this kind of problem. We'll be learning again in the laws of motion, and other 2 3 chapters are there. Okay, when we'll be solving this kind of problem. But here you don't have to put much effort. This is having simple formula and simple knowledge over here. You don't have to see, since the inclination theta is not given, the angle is not given, so you don't have to think in very complicated manner. So what they have told you that this is frictionless inclined plane. Okay, this is an inclined plane. This is called inclined plane. Inclined means it is slanting or inclined with the horizontal. Okay, so this is basically this guy. Okay, this is the one. Okay, this is the inclined plane. This is called inclined plane. Don't get panic. Okay, just by hearing inclined plane and all those things, we'll be learning this. Okay, this is these are the topics in our next, I think, fifth chapters. Okay, fifth chapters we'll be learning these things. Okay, don't worry, we'll be teaching you these concepts and all those things. Okay, so for the time being, so this is simply displacement. Okay, nothing else you have to think. Nothing else you have to think. So suppose the box start from rest, and if Sn be the distance traveled by the box between Tn minus 1, this is the time t is equal to n minus 1 and t is equal to n, then what is the value of this ratio? You have to find out Sn by Sn plus 1. This is the value you have to find out. Okay, you may not be knowing this. I'll just explain you what to do and how to do. What you have to first learn, what do you mean by Sn? See, we know this S is actually displacement. You know, we have learned the laws of motion in one dimension. This is, see, this is displacement ut plus half a t square. Okay, so this is the formula. So if you know the initial velocity, and if you know the time interval, and if you know the acceleration of the motion of the object, then you can easily find out what is the displacement of the object after some time t. So this is initial velocity. Initial velocity. This is the acceleration of the object. So this formula you are familiar with, I know, because I have taught you. And this is the time interval. Okay, after some time interval. If you are not able to remember, then you please go back and read your book or listen the lecture. Then you will find out what is this formula. This is the displacement at any instant of time. Displacement. Sometimes displacement is written as y also, or sometimes x also. That depends. Okay, but s is the standard notation for displacement, which generally is being used universally. All right. So I know this formula. So what is Sn? So what is this S actually? Actually, this S is the displacement. Is the displacement, this formula, from this formula, the S is the displacement during the whole time interval t. That means you have suppose started motion at 5 seconds, okay, and then so this is t1, and you stops your motion something like 20 seconds, after 20 seconds. So what is this time interval? This t means t2 minus t1. This whole interval, this will be 15 seconds, right? This is the t. This is the whole time interval during the time interval. So the formula you see here, the displacement, this one is not at any instant. Actually, I I, I have told you, uh, this is not instantaneous displacement. It is actually the displacement during an interval. Okay, during in an interval. Now this Sn is actually instantaneous displacement. Sn is instantaneous displacement. What does that mean? Suppose I want to write, I'll just erase this part. So only S was the displacement during a certain time interval. But what about Sn? Sn means the displacement of any object at nth second. Okay, nth second. Sorry, not at in nth second. Nth second means, suppose if I say fourth, this is fourth second does not mean 0 to 4 seconds. It does not mean that. It means only the fourth one. So 0, 1, 2, 3, 4. So fourth means just that particular instant. So here Sn means the displacement of the object at that particular instant, n instant. So Sn means displacement of the object in nth second. Okay, nth second, at or in whatever, nth second. Okay, so this is the not second, second, nth second. So how to define this Sn? We have formula for finding out displacement for particular time interval. I'll just give you a simple example and then I'll write the formula. Suppose you want to find out displacement at fifth second. So what do? You find out displacement in 5 seconds, okay, minus displacement in 5 minus 1, okay. So you want to find out fifth at fifth second. So this is 5 seconds. This is 4, 5 minus 4. That means, see, if you find out the displacement in time for 5 seconds, during the time interval 5 seconds, and displacement during the time interval 4 seconds, and just take the difference, you get the displacement exactly at the fifth second. Exactly at the fifth second. So similarly, if I want to find out the displacement in nth second, then what you have to do? You have to find out displacement in n second minus, you have to take minus of this Sn n minus 1, okay. Then you get the displacement at particular instant, that is n second. So how to do that? Look, I'll just not derive the whole formula. I'll just give you some home task also. So what I'll do, I'll just give you some clue and then finally write the formula itself. You have to go back and then do the homework. See, Sn means, as you have written here, so you have to find out displacement for n seconds, okay. So you have to find out displacement for n seconds. So you have to write Sn. So Sn means here Sn minus Sn minus 1. Okay, we'll put it here in place of n. We'll put t and n minus 1. Sorry, in place of t we'll put n. So see, this the formula is u n plus half a n square, this part, minus of, similarly, u t, in place of t I'll write this n minus 1. Okay, n minus 1, ut plus half a is the acceleration, t square means n minus 1 square, whole square. So you have to simplify this formula, sorry, this mathematics. Okay, you have to simplify it. If you simplify, then you will get what is Sn. Okay, so there is a general formula. So what we'll get, if you just, so n is actually here t, and n minus 1 is another t. Okay, so this is the thing. If you just do bit of simplifications, what you get is this Sn is equal to u, initial velocity, plus a by 2, that is the acceleration, by 2 into 2 into n, that is the time when you want to find out, okay, Sn. So this is this. Okay, this is the general formula. You have to remember. If you don't want to do all this, actually if you do all this like formulations or derivations, then you may not get time in your exam. So better to remember this. This is the formula to find out displacement of any object in nth second, and this is a, this is the acceleration, this is the initial velocity. So in this case, suppose the object here starts from rest, that means u is 0. So if u is 0, so for, so this is the general formula you should remember. So displacement of any object in nth second is given by u, that is the initial velocity, plus a, that is the acceleration, divided by 2 in minus 1. Okay, now this is the general formula. What we'll do, we'll use this formula to solve this problem. We'll use this formula to solve this problem. So the problem is here, see Sn, I have already explained. So the box starts from rest, that means u is 0. So our formula becomes now a by 2 into 2n minus 1. So similarly I can find for Sn plus 1. Okay, this I can find out a by 2. Now here in place of n you have to write n plus 1. So 2n plus 1 minus 1. So this is the thing. So if you do bit of simplification for this, so you will get a by 2, this is 2n plus 1. Okay, now if you take the ratio, so we have used this formula to solve this. Okay, look, this formula we have used to solve this problem. This is the final formula, and how to get this formula I have already told you in the derivation part. You have to learn from there. Okay, and you have to remember this final formula, the displacement at any instant of time. Okay, look, now I have to find out Sn divided by Sn plus 1. Take the ratio. So Sn is actually a by 2. This is 2n minus 1. This is a by 2, 2n plus 1. Right? So a by 2, a by 2 goes from both denominator and numerator, and this is the answer for the problem. Okay, this is the answer finally. So 2n minus 1 divided by 2n plus 1. This is the ratio. Okay, Deepa, do you understand this so far? Whatever I have done.
Yes, sir.
Okay, you are saying all the way yes. I have I have to pacify myself from your words. But anyway, if you don't understand also, you just see this lecture again, then you will be able to understand. Or you just, now you have got some idea, you just go back and read. Okay, read your book, then you will get this again properly. Okay, all right. So we'll be taking few more problems. Let us see. Okay, this problem related to our graph. Okay, so this problem I'll skip because unless we discuss the motion in plane, you may not be able to answer it. We'll go to this problem, sixth one. Okay, I will discuss the sixth problem. A body is thrown upward with an initial velocity 30 meter per second. What is the distance covered by the body in last 3 seconds? Okay, in last 3 seconds. This is the question. So how do you solve it? How to solve this problem? A body is thrown upward with an initial velocity. That means initial velocity is given. So what is the problem? Problem is that the body is thrown upward vertically by giving an initial velocity that is 30 meter per second. And see, this is under gravity. That means G is working. The acceleration due to gravity is working in the downward direction. Okay. So this motion is under gravity. This motion is under gravity. So what is the distance covered by the body in last 3 seconds during its ascent? Ascent means it is going ascending upward. So the question is in last 3 seconds. Look, in last 3 seconds of its ascent. That means, see what happens. We have already discussed that this object is moving upward, but acceleration is in the downward direction. That means your velocity will be decreased because this will act as deceleration. So G, the gravitational acceleration will act for this object as deceleration, right? It will, so it will decelerate. Suppose in the beginning it was given 30 meter per second, so this, which is this one. So it will lose. Sometime it will be, see, 25 meter per second. Sometime it will be again 20 meter per second. Sometime 15 meter per second. Sometime 10 meter per second. And at the highest point where it reaches, so there it will reach, and by that time the velocity, the final velocity will be 0. I'm denoting final velocity as v, initial velocity as u. So initial velocity will be changing, it will be reducing, and finally when the velocity becomes 0, that time it will stop. That means that is the highest distance it would have reached. Okay, that is the highest distance it will reach. Okay, so this, suppose this is the h height. So this h height, so this is a reference point, so it will be 0 here, height is 0 over here. So 0 to h height. Okay, so when it starts with 30 meter, it reduces velocity and it is managing to reach up to h height, and by that time the velocity of this object becoming 0. So you have been given G is g is 9.8 meter per second to be taken. U is given already, 30 meter per second. So we can find out the time, okay, the total time, okay, total time when it reaches up to this height. That means when it stops, that I can find out. So what you have to do, actually you have to find out the last 3 seconds what is the distance is travel. That means, in the last 3 seconds, when the last 3 seconds starts, suppose this is the time, whole time, and last 3 seconds is 1 2 3. So this is the last 3 seconds starts here, okay, last 3 seconds starts here. So you know I have to find out what is the velocity over here. What is the velocity, initial velocity over here? If I know this velocity, then I can find out what is the distance traveled here, right? Not only velocity, I have to even know what is the time it takes. Like, okay, so last 3 seconds it says, so if you know the u, then last 3 second, so t is here, last 3 second, you can find out. So when the last 3 seconds starts, that time what is the velocity? That is the main thing you have to find out over here. We know velocity over here is 30 meter per second, but it will not be here the same when it reaches up to some height, okay. That means this will be some velocity u prime which is less than the initial velocity. So we have to find out this velocity first, okay. To do that, you have to know what is the total time it takes up to reach this final height. So we can use this formula, v is equal to u minus gt. So v is equal to 0. So this implies we can find out t. I'll write here this as capital T. So capital T, that is the time it takes to reach up to the highest height, like the maximum height. So this is u by g. Okay, we are just going to derive a formula over here. We are not putting the values u, g and all those things. We are just going to derive a formula. Let us see how does it look. So last 3 seconds, I am just deriving this formula for in general. Suppose I have to find out the velocity, displacement in last 3 seconds, of travel. So then what you have to do, you have to find out the velocity when the last 3 seconds starts. So to do that, find out v is equal to, this is, was my voice not audible sometime? Okay, Deepa, are you able to hear me? Guna madam, is it audible still, or there is some problem? Deepa, I couldn't hear you.
Yes, sir.
Okay, good. Okay. All right. All right. Okay, so look here. We have to find out velocity. So we have got the total time, but at last 3 seconds you have to find out the displacement. So you have to find out what is the velocity when the last 3 seconds starts. So if you do that, you have to find out the velocity. So t minus t over here. So again, you can put the value of t from here. See, t is u by g. This is t. T is the capital T I am talking about, so which is u by z. This is separate part. If you simplify it, what you get is actually, see, u, so this will be minus u and this will be plus gt. So what you get is gt. So gt will be the velocity when the t second, small t second starts. Okay. Now you can find out. So now you can find out the displacement from there. Okay. Now you can find out from there. Look how we will find out. See, here st will be ut. Ut means this one, this b here now, minus half g t square. Okay. So this is again gt, u is gt here. So this is gt square minus of half gt square. So you'll get here half gt square. So this is the formula. Okay. So this is the general formula. Deepa, you can remember this. In any case, whenever there is a problem like this, that in a vertical motion, if some object is thrown with certain velocity, then what will be the displacement in last 3 seconds, last 4 seconds, last 5 seconds, etc. If this is upward motion, you can just simply find out where here it is in 3 seconds. So I can write s is equal to half g. This t is 3 seconds here in the problem. So I can write this half into g, you have to take 9.8. Okay, and this is 9 again. So this will be 4.9. So 4.9 into 9, you have to find out this. This is meter. This will be something like 4.4, 44, sorry, 44.4, 44.1, sorry, 44.1. So this will be the displacement in last 3 times, last 3 seconds during ascent. You have to remember this is ascending, during ascending. Okay, not descending, during ascending. Okay, this is the formula then. St is equal to half gt square. So we have used the formula St is equal to half gt square. You might be thinking, sir, why did you tell me this much about this, and then you are using just simply this formula? So why don't you teach me this simple formula? But you have to know why you are using this simple formula, from how it is coming, like from where it is coming and how it is coming. Okay, so that's why I taught you how to find out this formula itself. So I hope you are enjoying the class. Okay,
Yes, sir.
you can repeat this. Yeah, you can just repeat this lecture and see once again, then this may be again clear to you. So I'll just take one more simple problem. This is related to a relative motion problem. Okay, this relative motion we had learned recently. I hope you will get some idea to solve. See, a bus is moving with a speed 20 meter per second on a straight road. So bus is moving. Okay, a motorcyclist wishes to overtake the bus. So this is a crazy thing we do while riding bike. Some people tries to overtake, okay, all others and go faster. So a motorcyclist wishes to overtake the bus in 50 seconds. Okay, in 50 seconds. The bus is at 1.5 kilometer from the cyclist. 1.5 kilometer from the cyclist. Then what speed should the motorcyclist chase? Okay, at what speed the motorcyclist chase the bus overtake it. So first of all, let me explain. Suppose uh, here is the motorbike. Okay, I'm just giving a dot over here. So motorbike. So man in the motorcycle, and here is the bus. Okay, here is the bus. Okay, suppose this is the bus which is moving. Okay, so it is moving in this way. So the distance, so when the man wishes to overtake the bus, so that particular instant, the distance between the motorbike and this bus is 1.5 kilometer. This is the distance, right? All right. And see, this bus is moving with 20 meter per second speed, and by that time the motorbike has not started. Suppose it has to start moving. Okay, so what is the velocity of this man such that it can overtake the moving bus? Okay, overtake the moving bus. Or, so do you understand this problem? So the motorbike has to overtake this moving bus. Okay,
Okay, sir.
so this is the problem. Yeah, so this is the problem of relative motion. So I'll take the velocity. So relative velocity, if you remember, if both of them are moving in the same direction, so the relative velocity, suppose this is v bus and this is v man, both are moving in the same direction with certain velocities or speeds. So what is the relative velocity of the man with respect to the bus? Sorry, bus with respect to the man. Do you remember how to write this? The velocity of the bus with respect to the man. This has to be written as Vb minus Vm. Okay. So in this case, since the man is trying to overtake the bus, obviously the man has to start with a greater velocity than the bus. Okay. So I take the relative velocity of the man with respect to bus. So this is V man minus V bus. Now, how much distance it has to cover, and what is the time? 50 seconds. In 50 seconds, it has to cover. So this is the relative velocity. If both are moving, the relative velocity is this, and with this velocity, in 50 seconds, they have to, like, this motorbike has to overtake the bus. That means it has got 50 seconds. So motorbike has got 50 seconds to cover with this uniform. This is the uniform velocity or constant velocity. If you multiply with 50 seconds, okay, 50 seconds, then this has to be equal to 1.5 kilometer. Then only it will be able to overtake. Okay, so let us solve the problem. The numerical part will do. I hope you have understood the concept. So you have to first find out what is the relative velocity. How you write relative velocity of the man with respect to the bus, we have written as Vm minus Vb. With this relative velocity, if he wishes to overtake the bus in 50 seconds, so this velocity, relative velocity into 50 seconds has to be 1.5 at least. Then only it can cover. So this is kilometer. I'll write kilometer. So I'll multiply with 1000. Now see, Vm minus Vb is equal to 1.5 into 1000 divided by 50. So if you just remove this point, this will come here. So it will be this. So this is 30. 30. Now you have to find out V man. So this is 30 plus V bus. V is the velocity of the bus, that is 20 meter per second. So you will get 30 plus 20 meter per second. That means 50 meter per second velocity. With this much velocity, uniform velocity, obviously there is no acceleration we are supposing. This is the velocity. Sorry. This is the velocity with which the motorbike has to be driven so that the man can overtake. So this is the answer. B will be the correct option. Okay, 50 meter per second. So this was the problem from relative velocity. Okay, I hope you are understanding this and you will
Yes,
be
sir.
able to apply in future problems. So my advice will be to you, please find out this kind of problems. I have given one uh, problem sheets, okay, or quiz sheet on this. So if you get it from our site, you can just solve it and then you can like practice it. If you don't get any clue how to do, then you can ask me in the next class. Okay. So
Okay,
Deepa, you
sir.
please read the whole chapter and try to solve few numerical problems like this. Okay. I'll stop it here for today. Okay. So this is all for today. We'll meet again on Tuesday. Okay. That day we'll learn. We'll start a new chapter, motion in a plane. Okay. So bye for today.